Hi, welcome to Unit 3, Module 11. So today we're going to be talking about different ways of brain imaging, and also we're going to get into the different parts of the brain. Here are your learning objectives. Pause it if you'd like. And then here are your vocab. All right, so the first technique we're going to talk about is lesioning. This is really simple. So lesioning means destroying the tissue. And this is done for research purposes on other animals such as rats, not humans. And we can also do the opposite effect, which is to stimulate different parts of the brain. But lesion means destroy the tissue. It can also happen naturally if there was a stroke or a seizure. So when you think EEG, you should think sleep study, because that's really the most common one, especially the most common that will come up for you. So if you see this cute little baby has the electrodes on his head, and then that helps them study, it makes the brain waves like theta and alpha waves and delta waves, and you can tell what phase of sleep. They can use that to examine for sleep disorders. They can look at your brain waves for epilepsy. If someone was in a coma, they use it for determining brain functioning, if there is brain functioning. So another type of brain scan is the CT scan. So when you think CT scan, I want you to think of basically an X-ray for your brain. So any sort of brain damage, like structurally, they would use a CT scan. So PET, positive emission tomography. So this uses a little radioactive glucose that basically your body uses glucose, it uses it as energy, and so this radioactive glucose allows them to follow it and see where all of the glucose, all of the energy or activity is going in the brain. So if some parts aren't lighting up at all, so if you look at the Alzheimer's disease patient where there's just overall less activity in the brain, and like bluer is like a lower level of activity, red would be a higher level. So they can do this to check for a lot of things. Don't worry about the list that says check for. I just did that like in case you were curious. So CT scan was X-ray. This one, okay, an MRI is a very common tool that is used. You might have had an MRI done on some part of your body. So an MRI for the brain uses, just like all other MRIs, the magnetic fields and radio waves to produce this computer-generated image, and it's of the soft tissue. So it's more much more detailed than a CT scan. This is the same thing. It has the MRI aspect. You can see soft tissue, but it also reveals blood flow. And where blood flow is, there is also activity. So it kind of seems similar to the PET, because the PET does brain activity, except this one also shows you the soft tissue. So you get the soft tissue view at the same time you're getting the brain activity. So this one's used a lot. They did a study with the fMRI, and they scanned 129 brains using the fMRI, and they made people do 8 different tasks like reading or rhyming, gambling, etc. And neuroscientists, while looking at these people's brain, could identify which thing they were thinking about with an 80% accuracy. There was 8 options, and they were 8 right. So this is like a really useful tool to kind of see what brain activity is associated with like religious experiences, or people who say that they're speaking with God, or listening to angry voices. And we can watch on an fMRI and see what parts of the brain are active. They're thinking about scary things, happy things, pain, rejection. We can kind of like learn where those different parts of the brain, or which parts of the brain, are activated during those times. So it's a really cool, useful tool for us in psychology. Now we are moving to the different parts of the brain. And before we really get into the different parts of the brain, I want you to follow along with me while I show you a little trick. And please, can you just like follow along with me and do this, please? I know you're just sitting there and you're going to be like, no, I'm not doing that. Like, I'm sitting here watching a video. You can't make me. And you're right, I can't. But in class, I will totally call you out. You will be doing this in class because it really helps. And like doing these little things helps you. Okay, that's my stepping off the soapbox. So, 3 main parts of the brain. Go like this right now with your fist. So the first part of the brain that you need to know is the brainstem. This is your spinal cord, and this is the brainstem. So they are connected, okay? So that's the innermost part. This is the most primitive part, and it keeps us alive. I'm going to go over this more. The next part, so put your other hand over that hand like this. So the next part is called the limbic system. And the limbic system holds our more complex, so we're a little more evolved here, and they hold our more complex emotions like fear and aggression and some other things, other emotions. And then they also hold the 4 Fs, like feeding, fighting, fleeing, mating. Oh, and I actually added a 5th, furnace, temperature. So 5 Fs. So they hold those. And then our third most evolved and most complex part of our brain is, and this is where in class we need a partner, but we're just going to go like, we're going to pretend this is still here, and we're going to go like this, okay? And these are the 2 parts of our cerebral cortex. So the cerebral cortex is the highest level, the most evolved, and that's where all of our like judgment, planning, decision making, all that kind of high level thinking goes up here in the most evolved. So if you think of more primitive mammals, right, they're down here or here, and then we're here, and primates are here as well. So that's why we can study primates, and they're really useful. Let's go into these parts of the spinal cord and goes right in to the center of the brain. So when we're doing this, it's not just like sitting in the back here, it's like in the brain. So this is our like reptilian brain because it's the most primitive. So there are there's only 2 parts of this brainstem that you need to know. So in the brainstem, you need to know the medulla. The medulla controls our heartbeat and our breathing. Keeps us alive. If you don't have medulla, you're dead. And then the pons. The pons helps coordinate our movements. Okay? You do not have to know the midbrain. Okay? You just have to know medulla and pons. Okay, next, that sits on top of the brainstem, if you see this picture right here. So this is our sensory control center. It takes all incoming sensory info, because remember those sensory neurons send the message up the spinal cord, right? And so the thalamus gets all of that first before those higher level parts of the brain, because it's down here in our brainstem. So it gets all of that except for smell. So every other sense except for smell goes to the thalamus. And then from there, so I have a picture here of a mailman, and see that no sign over his nose. So he's the mailman. He delivers all the senses except for smell. So he does not have a nose. So he's Thad for thalamus. He's Thad the mailman, and he delivers sensory info to everyone except for... All right, so next we have the reticular formation. So this is inside the brainstem. It's like a network of nerves, and if you see this right here, there is like that little orange or whatever color that is, so it kind of goes up through the brainstem. So this controls our arousal, and by arousal, what I mean is just our being awake or asleep. So over here. So when they stimulated this on cats in the labs, they found that like they instantly were like awake and alert just by stimulating this part of our brain. So the cerebellum is that little like baseball or like mini brain type thing in the back of our brainstem. And that is, when you think cerebellum, I want you to think voluntary movement. For example, like a dancer learning her routine or playing soccer, right? Like those are movements that the more you practice it, the less you really have to think about it, right? So that's the cerebellum that's helping you out with that. Even just like walking, balance, coordination, all of that. Okay, so now that was the brainstem. Now this is the limbic system. So that's like our part 2 of our 3 parts. So the limbic system is where our more complex emotions are and our other like more basic drives. So we remember the 4 or 5 Fs. The 5 Fs being feeding, fighting, fleeing, mating, and furnace. 5. I don't know why I counted 5 like this without my thumb, but I did. There are 3 main parts to our limbic system. There's the amygdala, which I want you to think fear and aggression, and we're going to go over this. The hypothalamus, that's where our Fs are. And then our hippocampus, which is responsible for new memories. Not all memories. It's not like a little safeguard for all memories, just new memories. Okay, so the first one, let's talk about the amygdala. So the amygdala is responsible for our basic basic emotions of fear and aggression. They're like these 2 little lima bean sized clusters at the end of the hippocampus. So they're like those yellow buttons. And when researchers remove the amygdala from wild animals, they become completely like docile, lame, like just so mellow. So they're not aggressive at all. So if a cat's amygdala is stimulated, so the opposite of a lesion, right? If they're stimulated, then it could become aggressive. But if you move it a little bit in another direction, it will like cower at the sight of a mouse. So it's both of those emotions going on there. Okay, also in our limbic system is our hypothalamus. So this is where we get the 5 Fs. And you can see I changed it in my slides. Oops. So those are your 5 Fs like I went over. And there's like just stuff. So the limbic system they've also found is our reward center. There were 2 neuropsychologists who were like young guys in the 1950s, and they accidentally stimulated the wrong part. So when they did that, they realized that it kind of worked at this reward center. And this is kind of like funny but sad. When they studied this more, they gave rats this like pedal, and it could trigger that, stimulate that whole like reward center part of their brain. Like they could stimulate it themselves. And so the rats just freaking kept hitting the pedal until they literally dropped in complete exhaustion, did not have any energy left at all to push the button. 7,000 times they pushed the pedal per hour. Okay, so and then they also found in this nucleus accumbens. So they found these like little reward centers within the hypothalamus, but these ones are in front of the hypothalamus, and we share these with. So it's really cool research. It's also they're constantly learning new things about how it's tied to addiction and like kind of like working with that part of our brain to help people who deal with like alcoholism and drug addiction. And it's also no surprise so that's kind of where our dopamine is created, like our own dopamine, but then also like drugs like cocaine and heroin. So, all right, so what are our takeaways? So you should know the key differences in the brain tools, especially like, okay, so what would this show me, right? So an fMRI would show me soft tissue and it would show me activity, things like that. Many things people thought about the brain were actually debunked by those tools. Remember my hand trick that I know you're probably not doing, and I'm going to make you do it. And then the brainstem keeps us alive. That's a key one, right? Breathing, regulating heartbeat, all that stuff. The limbic system is our reward center, and all those Fs are in there. When in doubt, pick hypothalamus because it's got the 5 F's. Can't go wrong. All right, so I will see you in the next